Alrighty, in this video what we're going to be doing is taking a look at Android's build system. So we're not going to be creating a project from Android Studio, instead we're going to be creating it from the command line. But like I said in the last video, it's important to understand that these command line tools we're going to be showing in this video are the same tools that Android Studio itself will actually use in the background to perform various tasks, such as compiling your application and launching it. So in this video, we'll have an opportunity to talk about the build system, how it's used, how it's configured, what tasks you have available to it, and we can also take this as an opportunity to talk a little bit about ADB and to talk about the project structure of the application. So what folders do what and all that fun stuff. So let's go ahead and get started. Now, if you skipped the last video, it's important to know that I right now have two paths added to my path environment variable, one for platform tools and the other one for Android. And that's so I can access the ADB command line tool as well as the Android command line tool from any directory in my computer using the command line. So what I'm going to do is, again, we're not launching Android Studio. What I'm going to do is I'm going to pull over this folder here that I have that is located on my desktop. And inside of here, I'm going to shift right click into the white space and hit open command window here. And I'm going to issue a command to the Android executable or the Android bat file that we added a path environment variable for. So this is the command I'm about to invoke is one of the tools that we get access to by installing the SDK. So the command that I want to go ahead and invoke is not surprisingly going to be Android create project. Now, of course, there are a lot of command line parameters we're going to have to specify, because if I hit enter, you'll notice that I didn't specify a bunch of stuff, such as target, path, package, blah, blah, blah. So let's go ahead and give it what it wants, in addition to another thing here. So I'm going to go ahead with, I'm going to start off with -A for the activity name. So when the Android bat file or executable or jar, the template runner, whatever you want to call it, creates our project, it's going to create an activity for us, a blank activity. So I'm going to say main activity, which is typically what we use for the main activity names in Android. I've seen this name used as an activity for quite a few Android projects. The next thing I'm going to do is going to provide the K parameter. And again, if you look right here, you'll see what that is. That is the package name. So the package name is how your application is uniquely identified on the Android operating system. So your package name must be unique across all applications on the App Store, the Play Store, or any other applications that a user may install on his device. So what we're going to be doing with the package name, which is common for most other package names, is using the reverse domain kind of format that you see very commonly with Android projects. So like if your domain was, nelson.example.com, your reverse domain would be com.example.nelson. So what I'm going to do here is I'm going to say com.buzz. Now I'm using buzz because I can't use 3D buzz here. Let's just go ahead and give this a unique project name. So let's just say test1. It's a terribly generic project name, I know, but it'll work for our purposes. So this will uniquely identify our project on the device once it's installed. So the next parameter I'm going to want to give it is -t, which is our target. It's our target API level. So I'm just going to hit 21 or 19, or yeah, I'm just going to do 19, KitKat, because that's the thing that we have installed on our emulator. And then I'm going to go ahead and specify one more here, -p, and -p is the path of where we want to dump the project. And in this case, I'm going to do -p app1. Now you'll notice that I'm located right here on my command prompt, so that app1 will appear in a folder directly underneath it here. There's actually two more parameters that I need to specify. Now, there's a little bit of history behind how Android build systems worked in the past. From my knowledge, since I've started working with Android, we've always had some sort of build runner. Now, what do I mean by that? Well, you have tools. If you're familiar with any Java code or writing Java code, you might be familiar with Ant, for example, ANT, which is a build runner. It's a little command line tool that allows you to specify you can think of them like little scripts on your in an XML file, or in the case of Ant, it's an XML file, and you have these little scripts that you can execute from the command line and give parameters to. These build runners are used for just running tasks, or task runner, I guess would be a more appropriate name there. Other common task runners for different platforms include things like Rake for Ruby, or MS Build for .NET, or NANT for .NET, and so on. Well, Ant is a very popular task runner in the Java world, but and Android or Google used it for a while, but they decided to completely rewrite their build system and instead use a different product. And this different product is called Gradle. And Gradle is just a task runner. So again, the basic definition of a task runner is you write a file that's understood by the task runner, and it allows you to execute the tasks that you entered into that by executing a command on the command line. So Gradle is a interesting one. It's much more recent than Ant, and it's built on top of the programming language Groovy. And I don't know if any of you guys are familiar with Groovy, but Groovy is a language that compiles into Java bytecode, meaning that just like how C# and VB.NET both run on the .NET framework, Java and Groovy both run on the JVM. So they're compatible with each other. They're related, but Groovy has a much more modern and up-to-date syntax than Java, in my opinion anyway. And Gradle uses Groovy files to describe the tasks that can be ran from it. Very similar to how Ruby would describe the tasks that could be run from a Rake file. So if I were to just hit enter right now, what we would get is an Android project with Ant. And that would require that we have an Ant runner, or Ant task runner installed on our computer, and then we'd be able to execute the build for our project. But instead, what I want to do is I want to use the more modern Gradle build system, and that's what we're going to be using exclusively throughout this series. The modern Gradle build system provides us with quite a few awesome features, such as product flavors, which we'll be talking about in a very short in a video that'll be coming up very shortly. So to specify that we want to use Gradle, not surprisingly, we use -G, as you can see right here. However, in addition to providing -G, we also have to pass in -V for the Android Gradle plugin version. The current version that we're going to be using is going to be 1.1.0. So this version number that I'm putting in here is the version not of Gradle itself, so it's kind of misleading there. It's of the build tools itself, the actual plugin that Android uses to provide us with functionality inside of Gradle in order to perform our Android builds. I'll talk a little bit about that more when we open up our Gradle file and take a look at how we use it. Anyway, let's go ahead and hit enter. And we're going to get ahead, blah, blah, blah. Oh, wow. This -T isn't a API level. It's a little bit more complicated than that. And so, fortunately, they have I completely forgot about that, sorry. Fortunately, what they have is a very handy error message that tells us how to get a list of targets that we can use. So what I'm going to do is I'm going to type in Android list targets. And we see we have this right here. So what we can do is we can target ID 1 or Android 21, or we can target 2 or Google Inc. Google APIs 21. So these are the current versions of the SDK that we have installed on my computer at the moment, the current versions of Android and all of Android's sources. So what I'm going to do is I'm going to hit up a couple times and then replace that T19 with T1. Let's just go ahead and target API level 21. So I'm going to hit enter, and you'll see it created a bunch of stuff. So we created a project directory, we created a bunch of subdirectories because Java really likes its subdirectories, and created a bunch of files. So now if I move the window out of the command window out of the way, we'll see we have app1. So yeah, let's go ahead and cd into that. So this is our Android application. This is what you get when you just go ahead and create a new project without using an IDE with any other sort of magic in it. And again, I really like showing people this without having to use an IDE because it gives people a better perspective on what's going on behind the scenes. So we'll see a bunch of files in the root of our project, and we'll see two folders. We have the Gradle folder, which I'll talk about here in a sec. We also have our source folder. And inside of source, we have Android test and main. Under main, we have our Java and our res folder. And when we go over the project structure and our Android manifest, when we go over project structure, we'll talk about that too. But I want to focus on the root of the project right now. So we have build.gradle, gradlew, gradlew.bat, and local.properties. So I'll get the easy one out of the way first. Local.properties. If we open this up, you'll notice that it has a comment at the top of it saying this file is automatically generated, blah, blah, blah. Don't modify this file. Don't commit it to source control. Just leave it there to do its thing. So local.properties is very, very uninteresting. So then we have this gradlew and this gradlew.bat. So what are these? Well, gradlew stands for Gradle wrapper. Now, I might not have been clear earlier about how Gradle actually works or how you use it. Basically, what you need to do is you would need to download an installation of Gradle, a specific version of an installation of Gradle, and have it added to your path so you can execute it from your command line as Gradle space blah blah blah. But to maintain compatibility and to prevent us from having to do that step, as well as to allow us to really use whatever version of Gradle that we want within our as per project basis, what Google did is they created for us this Gradle wrapper. Now the Gradle wrapper will go ahead and install the version of Gradle that we've specified. And it'll just it'll install the version that we specified if it doesn't already exist, and if it does exist, it'll use it. Now the gradlew that you see right here is going to be a bash script that you would use on a POSIX operating system, such as Linux or Mac OS, whereas this gradle.bat is a batch file, something that you would use on Windows. So of course the gradle.bat is what we're going to be using for this series. And again, all it does is downloads Gradle if we don't have it already, and then acts as a wrapper to that downloaded version of Gradle, and that's it. It's just a really nice convenience. But then we have this build.gradle. So what is that? Well, remember how I said our task runners typically will have a file that describes what tasks a particular project can do. In the case of MS Build, for example, that would be your csproj file, which is really just an XML file that describes the build steps required to compile your C# application. If we were again talking Rake and Ruby, you would have your Rake file. Well, this is the build.gradle file, which again describes what the thing can do, what it exposes the tasks that Gradle can invoke. And it does so in the form of Groovy. So what I'm going to do is I'm going to right-click this over to Sublime Text, and then I'm going to hit Control-Shift-P and type in Groovy just to get Groovy syntax highlighting, which didn't really do much, but it'll do. So what is this? Well, this is a Gradle file. This file describes all the tasks that we can do with Gradle against this project. So you'll notice a couple interesting things here. We have this build script, and then we have repositories and dependencies. So what's happening here at the first line of this file is it's telling Gradle that there's a bunch of external code or repositories, Gradle repositories or Maven repositories. In the case of Maven, if you're not familiar with Maven, Maven's another build tool in the Java world, but typically since Maven Central hosts the majority of Java projects, Gradle has compatibility with Maven repositories, meaning this line of code right here, and remember, you're looking at executable code. This is not a DSL. This is Groovy, like actual executable code. What's going on right here is we're telling it that there's this place called Maven Central and it has a bunch of cool stuff, and if we ask for something and you can't find it, go there and grab it for us. And then we're immediately down here saying on dependencies that we're wanting to depend our build script on COM Android Tools build Gradle version 1.1.0. So this is telling Gradle right here that we want to load COM Android Tools build Gradle 1.1.0 from somewhere, be it a local location or Maven Central if it can't find a local installation of that, or another, you know what I'm saying. If it can't find it, it's like there's a hierarchy of where it'll look for that package, and in this case, it will default back onto Maven Central because it won't be able to find it anywhere. And Gradle will download the Android build tools. So this package right here contains all the build tools that we need to work with Android applications. Then we have apply plugin Android. So what does that do? Well, that just applies the build tools. This makes Gradle aware of the special Android build tools, and then this applies that to our Gradle build file. Now that's important, because remember how I said that the Gradle file specifies all the things that can be done with this project as far as the build system goes? Well, the apply plugin Android will take all the things that Android knows how to do, or the Android plugin for Gradle knows how to do, and makes it available within our own build script. So by apply plugin Android, we now, by that point, have a bunch of stuff that we can do. If I removed that apply plugin Android and removed the subsequent Android definition, there would be no tasks defined for this project because we haven't defined any tasks. Okay. After we apply plugin Android, then we have some Android configuration. So it's all a bunch of straightforward stuff that it's just Android configuration. That's it. It's configuration that's specific to how we want our Android project to be set up. Now, of course, we will be playing around with this a little bit later. All right, so we're not going to run Gradle just yet because there are two problems with the default Android SDK installation. Or there potentially could be two problems. We'll see if because I might have an older SDK on my other install. But on my other install of Windows, I had this problem, and we're going to have to fix it. First problem is this template was not designed for the build tools 1.1.0. Fortunately, there's not a whole lot of code here, so there's not a whole lot of things that could go wrong, but unfortunately something did go wrong. And that is, in the later versions of the Android build tools, the run ProGuard command was changed to, Minify enabled. So what we're going to do is we're going to change run ProGuard to Minify enabled. So make sure you make that change if you're wanting to follow along and actually run Gradle, because if you don't make that change and you try to do a build from this project, you will get an error. Now don't worry, the Android Studio templates are up to date, so you don't have to worry about that. Now the second problem is that not only do the latest build tools have a different property name for that, they also don't really work very well with the version of Gradle that gets downloaded by default by the Gradle wrapper batch file. So by default, the Gradle wrapper batch file is going to download an old version of Gradle that's unfortunately not going to work for what we want to do. So how do we fix that? Well, I mentioned before that it's actually pretty simple to change the version of Gradle that we use with the Gradle wrapper. And to do that, we go into the Gradle folder, the wrapper folder, and we see Gradle wrapper.properties. Now I'm going to drag this over to Sublime Text, and we'll see that there's this distribution URL right here. So instead of using Gradle.1.12-all, I'm going to change the distribution URL to Gradle 2.1. So 2.1-all.zip. Make sure you save that file. If you don't save that file, bad things can happen. Well, bad things won't happen. It'll just download the wrong version of Gradle, and then you'll get some weird indecipherable error and spend 30 minutes, running around Stack Overflow trying to figure out why your Gradle build stuff is not working. So anyway, make sure you go ahead and make that change. Again, this is under the Gradle wrapper, gradle-wrapper.properties file in the distribution URL property. Once you change that, it will download the proper version of Gradle. Now, you might be asking why you can't install Gradle local or globally on your system, and you certainly could, but I would advise using the Gradle wrapper whenever you are working with your Android project, because there might be specific versions of the Android build tools that are dependent on a specific version of Gradle. And because of that, just get in the habit of always using Gradle w.bat instead of a global installation that you may have installed on your computer. Okay, so it's unfortunate that I had to get through all of that talking just to start using Gradle, because what I really wanted to do to drive home the point about what Gradle is and what Gradle does is I want to go ahead and list all of the tasks that this project can run now because the Android plugin was applied. So all the things that we can do with the build system. Now, this is important both for your understanding of how Android works, but also from the perspective of if you wanted to ever automate the installation, deployment, testing, or compilation, or packaging, or release packaging, or anything of an Android project. So let's say you have a continuous integration server set up. Well, this is how you would set up your continuous integration server. You would use your Gradle W wrapper along with your Gradle build file itself. So let's go ahead and do that. There's going to be a lot of scrolling text on the screen when I type this command in, but just know that what's going to happen in this order is A, Gradle W is going to download that version of Gradle that I specified and stick it in a local folder. B, Gradle is going to download the Android build tools, and then finally, Gradle is going to perform the task that I ask it to. Now, the two things I said first won't happen the next time I run a Gradle task. So, I'm going to say Gradle W for Gradle wrapper, tasks, and hit enter. So you see the first thing it's doing is it's downloading the Gradle21all.zip. I'm not sure about all these dots. I figure that if it's wasting all that time printing out to the console, unless it's running the download on a separate thread, it might be a whole lot of waste of time. Anyway, you see that it's unzipping stuff. It's dumping it in it's actually not dumping in a local folder here. It's dumping it in a folder specific to my user. So just know that if you ever have a problem with your installation of Gradle, if it becomes corrupt, all you can do is simply go to your .gradle folder and you can go ahead and nuke it and then re-download it. Now it's downloading the build tools. So all of the build tools, you can see it downloading. You see it has a lot of dependencies. And then you see it fails. The reason why it fails is... Oh, nah. Wow, I messed up. It wants Gradle version 2.2, not 2.1. Okay, let's go back to our Gradle folder, to our wrapper folder, reopen up our properties, and change our distribution URL to 2.2-all. I guess there's a even newer version dependency. See, this is all the fun stuff that you don't have to worry about when you have IDEs, but when you don't, you kind of have to, get your fingers a little dirty. Okay, or hands a little dirty. So let's go ahead and run this again. So now you see it's downloading Gradle again. Because I changed the distribution URL, it's now looking for a new version that's not installed. So now it's unzipping. Super fun stuff to watch. I'm sure you guys are all excited about all this stuff. Anyway, I know for a lot of you guys, you're like, why are you spending so much time at the command line and the SDK tools and Gradle and all that fun stuff? Well, I really do believe it's necessary to at least have heard the words that I'm saying right now at one point. Because things can and will break, and you'll get some weird error in IntelliJ saying Gradle blah, 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 Gradle, Android build tools, blah, blah, blah. And at least now you'll have an idea of where to look. Okay, so remember the command I typed in was Gradle W tasks, which Gradle W tasks, anytime you execute a Gradle command, it's going to look in the current folder that we're in, which as you see on the command line, we're in the app1 folder, and it's going to look for a build.gradle file. So although I didn't specify build.gradle manually, it did look it up automatically. And when you run Gradle tasks, what you get is a list of all the tasks grouped by their category. So you see a bunch of Android stuff. Again, this was imported from the Android plugin. So we have things like Android tasks. We can display the Android dependencies of the project, or displaying the signing for info for each variant. It's really exciting stuff. We have our build tasks, which the assemble task is going to be the task in which we use to compile the package. And we'll talk about that here in a second when we do assemble. So what this assemble will do is it'll assemble all variants of all applications and secondary packages. That means it's going to assemble everything. Debug, release, all your flavors, all that fun stuff. But then we can get a little bit more specific. We can assemble our Android test project, which we're not going to be talking about in this series. We're not going to get into unit tests. But when this project comes with a unit test project, which we could assemble if we wanted to. The one we care about the most, however, is right here, assemble debug, which just assembles our debug builds. We also have the corresponding assemble release. So another couple other common things, such as clean, which deletes the build directory if you ever start getting weird errors about some intermediate files. You might want to do a clean. Blah, blah, blah. And we'll also have our install tasks. We have help tasks. That might be interesting for some people looking into trying to debug something, like display the components produced by the project, display all dependencies, and display all subprojects. Then we have install tasks, which, not surprisingly, install things to every single connected Android device. So when you run one of these install tasks, which we'll be running later, not right now, but when you install one of these things, it'll do it on all connected Android devices. Okay, so let's go ahead and do Gradle W assemble debug. And so that's going to go ahead and that's going to compile a debug build of our project. So I'll go ahead and hit enter. And you see it runs a bunch of these subtasks, and it was successful. You'll also have noticed that a folder appeared right here called build. So let's go ahead and open that up. So we have a bunch of stuff. We have generated, intermediates, outputs, and temp. Now, I don't know. I'll go ahead and go on this little slight tangent for a moment here. We see this generated folder. What's in it? Under source, we have this R folder. And under R, we have debug. And then we have what's starting to look like a Java path. Com, buzz, test1, and then we have this r.java. Remember in that quick start video how we had those magical IDs that we could statically reference through a constant just magically appearing in our project and accessible from our project despite the fact we just edited an XML file, which would seem slightly impossible for anyone familiar with XML and Java. It doesn't seem like that's something that should happen, but it does happen, and this is where the magic comes in. The build process actually generates this r.java file and has a listing of every single resource that's been created. So resources also include things like IDs. And in this case, you also see a layout resource, which corresponds to the layout XML file that was generated by the project template. And if I had IDs inside of this, like controls that had IDs so I could reference them from Java, they would appear here as well as constants. So we have those. We have a couple other generated things. We don't need to worry about the Android interfaces. They're not Java interfaces. AIDLs are this interesting cross RPC style thing. It's actually pretty cool. Then we also have like build config, for example. So our build config allows us to do something like type in the word build config, and we'll have constants that specify all of the attributes of the current build, and this is automatically generated. So if you ever wanted to know if you were in debug mode or not, you could always type in buildconfig.debug, and it'll tell you, depending on how the application was built. Anyway, so these are just generated project files or generated Java files. We have our intermediates, kind of boring, just a bunch of intermediate compilation code. We have our temp, kind of boring, just a bunch of temp code. And then we have outputs. And in our outputs, we have our APK folder, which is the interesting bit. Let's go ahead and open this up. Okay, so we have our APK. So what is an APK? Well, an APK is our Android application. You are looking at the Android application, the actual application that gets sent over to your phone and installed and turned into something that you can click on your launcher or your home screen. This APK contains every single little bit of information, all the code, all the resources, all the layouts that's required to run your code. In fact, it's interesting to note that the APK format is very similar, if not exactly the same as the jar format, the compiled Java archive format, which you guys might be familiar with. In fact, I could right-click on this and go into 7-zip and say Open Archive. And I can look at the actual archive that represents our application. So you'll notice we have a couple interesting things. We have our meta-inf, which has like certificates and stuff like that you don't need to worry about. We have our res folder, which contains our resources, such as our layouts, and you see main.xml right here. Fun note here, though, the XML files that are dumped into the compiled APK are turned into a binary representation of XML. So I couldn't just extract this and look at it. In fact, I could show you that. If I extracted this main.xml and tried to open it up in the text editor, we see it's a binary file. Anyway, slight tangent there. So those are resources, and we have our Android manifest, which we haven't talked about yet. We have more resource files for other kinds of resources that are compiled into this binary package. And then we have our classes.dex. Now, our classes.dex contains our actual source code, but compiled in such a way that the Android's VM, Java Virtual Machine, can interpret it. You'll notice that it's not the same thing as a jar, because if you're familiar with Java, a jar is just a archive that contains a bunch of .class files, and a .class file is the compiled form of a class. Well, in the case with Android, all of that's stuffed into a format called dex. There are Android decompilers out there, though, that you can use if people are interested in using or tearing apart Android code or any sort of fun stuff like that. So anyway, that is an APK. So what kind of interesting things can we do with an APK? Well, I think the most interesting thing we can do with an APK is we can shove it on a phone and run it. So let's do that. I'm going to go ahead and launch Genymotion and load up my phone. I probably should have done this off screen earlier, but I forgot. So instead, I'm just going to hit start and hopefully talk long enough for this to start. Okay. And we're going to learn our first ADB command. So I have the phone started right here. And let's go ahead and what we're going to do is we're going to use the Android debug bridge, or ADB, to communicate with that device. What we're going to do with that is we're going to take this APK and we're going to forcefully install, or not forcefully, but we're going to install it on the device. This is useful especially for people who may be downloading other people's Android applications from off the internet but not through the Play Store, and are interested in how to install those APKs onto their device. A lot of you may already know how to do this, but I'm going to go through it anyway. Well, honestly, though, the command couldn't be simpler. Basically, we're just start off with ADB, and if you just hit enter, you'll get this very long list of commands you can do with ADB. You can do a lot of fun stuff with ADB. Also, before I install, I want to do ADB devices. Now, ADB devices will list all of the virtual devices and physical devices that we have. It'll also list devices that are attached via network interface, such as Genymotion. Genymotion automatically registers its virtual machines with ADB for us, so we don't have to manually attach over a network adapter. And this will show physical devices too. So you see that we have a device right here, and it's identified by its IP address, which is on a local network local to my computer, because it's running through VirtualBox. So if you had a physical device, you would see that here. If you had an emulated device, you'd see that there too. It's important to understand this, though, because with ADB, any command that you have has to specify the device unless there's only one device listed. So that's important. I find it's typically a lot faster just to, if I need to run a lot of ADB commands against a device, to unplug or shut down all the other devices so I don't have to constantly tell it which one to use. There might be a way to change the default one, I'm not sure, but that's what I do because it's stuff and things. So let's go ahead and install this APK. How do we install an APK with ADB? Well, we install ADB, install the APK. So type in ADB, and then type in install, and then give it a path to the APK, which, since we're in the app1 folder, the path is going to be build/outputs/apk/app1.debug.apk. And let's go ahead and enter. And you'll see we have successfully pushed it. So if I bring down my device, you'll notice nothing changed, except when I open up my app launcher and I scroll over, I think it's going to be main activity. So main activity is the application I just pushed. So let's go ahead and click that, and it says Hello World main activity. Okay, so before we sign off on this video, because I think this ran a little bit longer than I expected it to, I want to go ahead and make a small change to our activity and recompile and reinstall. And then also make another change and show you guys how to install directly from Gradle, which we will be using from here on out. So we're not going to use ADB anymore to install the APK, we're going to use Gradle instead. So what I'm going to do is I'm going to make a change to this project. So I'm going to go open up source, main, I'm going to open up res, layout, I'm going to go here with main, and I'm going to open it up in a text editor. And you see we have a linear layout and a text view, and they're not indented properly, and that really bugs me. Also, it also bugs me when they put their ending tags on the same... Okay, so what I'm going to do here is I'm going to rewrite this text. I'm going to say, hey there. And I'm going to hit Control-S. Now I'm going to come back here, and I'm going to say Gradle W, assemble debug. It'll go ahead and compile it. Then I'm going to hit up 2 more times to where I have this ADB command already written. And I'm going to hit enter, but it's going to fail. It's going to say install failed already exists. And the problem with that is, well, the APK already exists on the device, so it won't rewrite it. We actually have to use a different command in order to update an application that's already been deployed on the system. Basically, I'm going to hit up again, and I'm going to go ahead and move my keyboard cursor on the window all the way to the left after install, and I'm going to do -R, presumably for reinstall. So let's go ahead and hit enter. And you see, this time it was a success. I don't know why they make you do that. It seems kind of silly to me, but whatever. Anyway, now we can come back here and open up main activity, and we see our modification right there. So that's really cool. So the last thing I want to show you guys is how to do this from Gradle in one command. So remember that when we do Gradle W tasks, we get a list of all the things we can do with the current Gradle file that's located in the directory that we're in. And you'll see that the ones that we're interested are going to be the install tasks. So what I'm going to do here is I'm going to change the text yet again. And I'm going to come back here, and I'm going to type in Gradle W install debug. Hit enter. So now not only is it going to compile the project, it will also install it for us. And this time it's going to install it on all active devices, or all devices that are plugged in. Now it still won't launch the application, but it did install it. And I can prove that it installed it by launching main activity again, and seeing on the text, this is a change in text yet again. All right, I hope I'm not boring you guys out of your minds with this awesome sort of low-level details about how to use Gradle and how to use ADB. I hope you guys enjoyed the video, and in the next one, we are going to be talking a little bit more about the project structure and the Android manifest. So yeah, we'll see you guys in the next video.